Mark your calendar, April 17th, 2026. Tesla opens reservations for a $12,749 car with batteries rated for 45 to 90 years, aerospace-grade chassis that never rattles, and AI that predicts failures months before they happen. Americans over 55 bleed $12,297 yearly on gas, insurance, and repairs that vanish overnight. This car eliminates all of it. Here's what dealers pray you never learn. What happens when a vehicle is engineered to outlast you? When there's no oil changes, no transmission failures, no reason to ever buy again? A leaked executive memo from Gigacasting confirms production costs locked at $9,200 per unit. Tesla's been running this vehicle through 18 months of testing with one specific target demographic: American men over 55 who refuse to buy electric. The reasons are always the same: too low to climb into without knee pain, too expensive when something breaks, too loud on freeways, too confusing with giant touchscreens. Tesla's engineers studied every complaint, every returned lease, every angry forum post. Then they built a car that solves all of it while costing less than a used Camry. Think about what that means for the traditional auto industry. Dealerships make 49% of their profit in service bays. Oil companies need you at the pump every week. Banks love those 72-month loans at 7% interest. This single vehicle threatens all three revenue streams simultaneously, and the panic is already starting to show in quarterly earnings calls where executives avoid questions about Tesla's manufacturing efficiency gains. The real story isn't that Tesla built a cheap car. The story is how they achieved something the industry claimed was impossible for decades. A single 9,000-ton Gigacasting machine replaces 70 separate stamped parts. No wells means no weak points that crack after 100,000 miles. No bolts means no rattles after years of rough roads. Just one solid piece of aerospace-grade aluminum alloy with tensile strength of 450 megapascals, stronger than steel frames in most compact cars. Each casting cycle takes 80 to 90 seconds, producing 40 to 45 complete chassis sections every hour. Traditional auto plants need 8 to 12 hours to assemble what Tesla casts in 90 seconds. What's fascinating here is that Tesla isn't using exotic materials or secret technology. They're using physics and manufacturing logic that's been available for years. The structural battery pack becomes the load-bearing floor, distributing crash forces like a fighter jet fuselage. Torsional stiffness hits 45,000 Newton meters per degree, literally double a Honda Civic or Toyota Corolla. This means less flex when cornering, zero rattles even after 200,000 miles, and a car that feels rock solid from day 1 to year 20. The entire body weighs just 220 to 240 kilograms, cutting energy consumption by 2 to 4% at highway speeds while keeping interior noise down to 64 to 66 decibels, quieter than your living room. In crash testing, this chassis absorbs impact energy equivalent to an SUV hitting you at 37 miles per hour with controlled deformation, keeping the passenger cell intact. They're not building a budget car. They're building a $60,000 vehicle and selling it for $12,749 because the manufacturing process finally allows it. The implications are staggering when you consider that Ford and GM are still welding together hundreds of parts, while Tesla casts the entire structure in less time than it takes to brew coffee. The technology integration is where things get genuinely interesting. Phantom braking has been every Tesla owner's nightmare since the Model S launched. The car slams on the brakes for absolutely no reason on the freeway. Dangerous, embarrassing, and Tesla's biggest black eye in customer satisfaction surveys. After years of complaints and negative press, the Model 2 eliminates this with FSD supervised version 14.2.1. Trained on millions of real-world driving miles with 10 times more neural network parameters than previous generations. 12 high-resolution 360-degree cameras work alongside upgraded millimeter-wave radar that's 50% more precise than earlier versions, ultrasonic sensors for parking, and for the first time in an affordable Tesla, short-range LiDAR in the front bumper. All data flows into a neural network with triple-layer cross-verification. Cameras detect obstacles and read signs. Radar measures exact distances. AI predicts what other vehicles and pedestrians will do next. In 180,000 kilometers of real-world testing through rush hour, construction zones, and bad weather, this system eliminated phantom braking 100% of the time. Zero false stops. Think about what that means for Los Angeles or Bay Area commuters spending 12 to 15 hours weekly in stop-and-go traffic. Your commute becomes genuinely relaxing instead of white-knuckle stressful. The system includes arrival options that automatically choose the best parking spot, customizable speed profiles ranging from chill to hurry mode, and improved hand gesture recognition. The LFP battery delivers 300 to 350 miles real-world range, enough for a full week of commuting or a solid road trip with charge time hitting 0 to 80% in 25 minutes on a supercharger. But the detail that reveals Tesla's design philosophy most clearly is something most reviewers will never mention. Bloomberg reported over 140 complaints from Model Y owners about electronic doors stuck when power failed during crashes or fires. Kids and elderly passengers couldn't get out. People were trapped. Instead of issuing recalls or fighting lawsuits, Tesla completely redesigned the door system for Model 2. Hidden in the door trim sits a small stainless steel mechanical latch requiring less than 5 kilograms of force to pull. No electricity required. Your 72-year-old mother could do it one-handed. A 10-year-old child could do it in a panic situation. Tesla ran 10,000 simulated emergency scenarios at Gigacasting involving total power loss, fires, and rollovers. The manual backup worked 99.8% of the time. In real crashes, it lets passengers exit in 3 to 5 seconds, cutting potential injury risk by 40%. Why doesn't every EV have this? Because it costs an extra $47 per door in parts and engineering time. Most automakers won't spend it on a safety feature that only matters in rare emergencies. Tesla made it standard equipment because the alternative creates liability they refuse to accept. This is the difference between engineering for profit margins and engineering for real-world consequences. The battery technology is where Tesla's long-term strategy becomes undeniable. Current lithium-ion batteries degrade to 80% capacity after 1,500 to 2,000 charge cycles. For daily chargers, that's noticeable range loss after 3 to 4 years, which conveniently aligns with when manufacturers want you buying new vehicles. The Model 2's sodium-ion batteries use salt-based ionic liquid gel electrolyte with a boiling point above 250 degrees Celsius. Because this doesn't evaporate, chemical stability improves dramatically. These batteries handle 3,000 to 5,000 full charge cycles before dropping below 80% capacity. With a 75 kilowatt-hour battery pack, that's 1.4 to 2.8 million kilometers over the battery's lifetime. The aluminum-ion battery option in advanced development carries 3 electrical charges instead of 1, enabling ultra-fast 20C charge rate for a complete full charge in approximately 7 minutes. These batteries achieve 9,000 to 10,000 charge cycles with less than 10% degradation. If you drive 12,000 miles annually, the American average, this battery will last you 45 to 90 years before needing replacement. Your grandchildren could inherit this car and still have 70% battery capacity remaining. This isn't planned obsolescence. This is engineering that destroys the entire business model of selling new cars every 5 years. The ergonomic details show how deeply Tesla studied their target demographic. The driver's seat sits 25 to 30 millimeters higher than Model 3, with final height at 620 to 680 millimeters, actually taller than the 2024 Corolla at 600 millimeters. Ground clearance measures 155 to 160 millimeters, handling 4 to 5 inches of snow without scraping. The hip flexion angle drops by 8 to 10 degrees compared to Model 3, which sounds technical until you realize what it means for anyone between 65 and 75. Significantly less lower back strain when getting in and out. Tesla's biomechanics team ran 847 ingress-egress cycles with test subjects aged 58 to 74. The result proved 91% said Model 2 felt easier on their hips and knees than their current sedan. Both front and rear doors open to a full 85 degrees, which is 15 degrees wider than most compact EVs. with 3 holding positions at 35 degrees, 60 degrees, and 85 degrees. Each detent holds with 15 to 25 newtons of force so your door won't swing back on a slope or hit the garage wall. The hip-level door opening measures 720 to 760 millimeters wide, with step-in height at just 450 to 480 millimeters. A Honda CR-V sits at 510 millimeters. That 30 millimeter difference is massive for anyone with arthritis or knee replacements, and it's the kind of detail traditional automakers ignore because their design teams are dominated by 30-year-olds who've never experienced joint pain. The acoustic engineering rivals luxury sedans costing 5 times more. At 70 miles per hour on the I-405 near LAX, pre-production test data shows cabin noise measured at 68 decibels. That's quieter than a 2024 Lexus ES350, which registers 70 to 71 decibels. Current Model 3 standard range hits 73 to 74 decibels at the same speed. Model 2 achieves 5 to 6 decibels quieter performance through laminated glass cutting 2 to 4 decibels in mid to high frequency range where wind roar and tire hum dominate. The underbody panels covering 78% of the floor eliminate low frequency boom between 250 to 500 hertz. 8 millimeter wheel well liners with honeycomb dampening handle the rest. You can talk in a normal voice at highway speed and be clearly understood. Podcasts play at volume level 12 instead of 18. The predictive maintenance system represents the final nail in the traditional dealership model. Over 200 sensors monitor every critical component, including battery cells, motors, tire pressure, brake pads, cooling systems, and suspension wear. Sensor data feeds into an AI neural network analyzing patterns in real time. It doesn't just tell you when something breaks, it predicts when something will break weeks or months before it becomes a problem. When issues develop, it automatically sends over-the-air software updates through 5G or Starlink, downloading in 15 to 30 minutes overnight. Software optimizes charging to extend battery life, adjusts regenerative braking to reduce mechanical brake wear by 10%, and updates terrain mapping for the suspension system. Over-the-air updates save Tesla owners $2 billion in repair costs between 2020 and 2025. For Model 2 owners, projections suggest average savings of $1,200 per year versus gas cars. No oil changes, no transmission fluid, no spark plugs or timing belts. Most issues handled automatically without visiting a service center. This is why dealership associations have spent millions lobbying against direct-to-consumer EV sales. They're not protecting consumers. They're protecting the service bay revenue that keeps their business model alive. The pricing strategy destroys every assumption about electric vehicles. Everyone remembers what happened with Model 3, announced at $35,000 but ending up at $46,990 by the time most people could buy one. The Model 2 launches at $12,749 for the base configuration, less than most used Camrys and Accords on dealer lots right now. The new LFP battery pack at 53 kilowatt hours costs 31% less than the 2023 equivalent. CATL is ramping production in Nevada specifically for Model 2. Tesla's locked in supplier contracts through 2027 covering steel, glass, motors, and batteries, with no surprise cost inflation built into the agreements. Elon's been clear in internal emails that Model 2 succeeds only if it stays under $13,000 base price. That's the non-negotiable line. Reservations open Q2 2026 between April and June next year, with $500 fully refundable deposits. First deliveries start October 2026 with California, Texas, and Florida getting priority. Tesla's targeting 8,000 units per week by December 2026, producing 32,000 cars per month to clear the reservation backlog in 6 months for early orders. Model 3 reservations hit 450,000 in the first month. Model 2 will likely break that record because the price point makes it accessible to demographics who've never considered Tesla before. What happens to the used car market when new vehicles cost less than 3-year-old trucks? What happens to dealer networks when customers stop needing service appointments? What happens to oil companies when a $12,749 car eliminates the need for gas stations? The Model 2 isn't just another electric vehicle. It's a systematic dismantling of the 100-year-old business model that's been draining American families dry. So here's exactly what happens when a vehicle is engineered to outlast you. The entire automotive business model collapses. No more $1,025 monthly payments bleeding you dry. No more dealership service bays extracting profit from your repairs. No more planned obsolescence forcing you into new cars every 5 years. April 17th, 2026 isn't just a reservation date. It's the day American families stop getting robbed by a system designed to keep them broke. Tesla's proving that affordable doesn't mean disposable, and that's terrifying every executive from Detroit to Tokyo. This is just the beginning. When Model 2 hits production targets in late 2026, watch Ford and GM either copy this manufacturing process or disappear. The next 24 months will decide which automakers survive the transition and which become cautionary tales in business school textbooks. Here's my question for you. When a $12,749 car outlasts vehicles costing 5 times more, what happens to luxury brands still charging premiums for features Tesla includes as standard? Drop your predictions below. This is Tesla Zone, where we break down the engineering that's rewriting the rules. For the latest developments as Model 2 moves toward production, you know where to find us. The era of cars designed to break ends in 2026. What comes next changes everything.